Now we're gonna find the volume obtained by rotating a region about the y-axis. Okay, in our case now we're gonna rotate the function y equals x squared. So this is y equals squared between y equals 1, and let's assume for clarification or for simplification that this is y equals 9. Okay, in this case this is our region here, and we're gonna obtain something that looks like this. Okay, and it's gonna keep getting bigger and bigger. So this is the volume that we're gonna obtain. Okay, it's like some ball, but not exactly. It doesn't have this it doesn't have this base. It's located between y equals 1 and y equals 9. In our case now, the cross-sectional area is gonna be, let's say it's let me do it in so it's gonna be a circle. Okay, let's say this is my point here, and this is gonna be, so this is my x. Okay, so I have to, this is x now, it's in terms of x, so I need to transform this one. So x is gonna be the square root of y. This cross-sectional area, it's gonna be in function of y. Okay, it's gonna be a circle that has this radius, which is x. Okay, but x squared, because I need to square it, but x squared is just square root of y squared times pi. Okay, and after that, this is the cross-sectional area. If I multiply that by let's say a square root of y squared times pi, if I multiply by a small delta, I get the volume, the small volume. Okay, and it's gonna be something like, let's say something like this. Okay, so it's gonna be something like this. Okay, this is my delta y. Okay, so if I sum up, I'm gonna obtain the whole volume. Okay, in this case the volume is gonna be, so I'm gonna integrate between 1 and 9. The square root of y squared is just y, and half pi dy, and I think that's it. Okay, my cross-sectional area. So this is the small volume. Okay, this is my sectional area. This is a small volume, delta V, when I multiply by delta y, and if I sum up, I obtain the whole volume. Okay, so this is why I integrate now between 1 and 9. So here pi is constant, and integrating y dy is gonna give me pi y squared over 2 between 1 and 9, and I obtain pi over 2, 81 minus 1, which is 80. So 80 over 2, that's 40 pi. And this is the volume that I obtain, 40 pi. Okay, so it's the same as in the x-axis. All we need to now is to find the cross-sectional area and multiply that by some delta y and sum up to get the volume. Okay, and use this one as our Riemann sum. Okay, and I think that's it. If we here, the only thing that is, we need to transform this function, that's function of x, into some function of y. Okay, and because you need, this distance is in function of x, but you want to integrate with respect to y. Okay, so that's why we have to transform x to y, and this is the only thing new here, except the only exception is this one here. That's it, nothing new. And thank you very much again.